Hello everyone. Continuing on our chapter 4 integration, we are going to look today on section 4.2, which is area under the curve. Okay, so the topics we are covering today will be using a sigma notation to write and evaluate a sum, understand the concept of an area, approximate the area of a plane region, and finding the area of a plane region using limits. So let's start with a sigma notation. So here we are going to look at a concise notation for sums. This notation is called sigma notation as it uses the uppercase Greek letter sigma. So when I say the sum of n terms a1, a2, a3 up to an, it means summation I from 1 to 1 ai, a1 plus a2 plus a3 plus an. Okay, so let's look at a very simple example first to get the idea of what we are looking at. So suppose I want to add, say, 1 plus 2 plus 3 plus 4 and say 5. Now that's easy to add, right? So it's 15. Okay. How about if I have to add, say, 1 to 100? And that scenario, would you like to write that? Say I want to add the first 100 terms, the natural numbers, 1, 2, blah. So I will be tired writing this up to 100. And then again, it's going to take me a long time to get the answer. So we're thinking, if we have to do all this, is there a way we can make our lives easier? So the first thing we learn is, suppose I had to write these. Can I write it in a very concise form? Yeah, the answer is, let's look at this one. So it's 1 till 5. So I'm going to start with this one and then show you this. So notice what is this. So if I write 1 plus 2 plus 3. Okay, so here's the scenario. Let's look at the scenario. So I can write this as, my I can be 1, I can be 2, I can be 3, I can be 4 and 5. How do I notate that this is, I'm adding the numbers from 1 to 5. The addition part, which is represented by the sum notation. This is what it means, that every time the I changes, there should be an addition between the numbers. So I say, so the thing is, where should my I start from? So we say, hey, I should start from 1, okay? Now if I want to write 1 till 5, so okay, 1, what is the next number? By default, we're always in the natural numbers, guys. Keep that in mind. 1 plus 2, okay, I have to continue. So I say, I want to just continue till 5. So 3 plus 4 plus 5. Now, suppose this was not numbers, it was some variable like this, a sub I. So here's notice my a is constant, but the subscript is changing. It starts from 1, goes till n. So instead of writing a1 plus a2 plus a3 plus an, I can write in this very concise form, which represents the sum of the first n terms. Do you see that here? Okay, so let's look at some interpretations of these. The symbol summation, which is the Greek letter, is the summation symbol. I here is called the index. So this I, guys, is the index of the summation. AI is the function of the expression which keeps on changing. Here my I was the sum of the first 5 numbers. So this is called the summand. And 1 is the lower bound. That means where I'm going to start from. And where I'm going to end is called the upper bound of the summation. So let's look at some examples. So here is, I want to add the first 6 terms. Summation is the addition symbol between the terms, which is basically the summand here. We start from 1, we continue till 6. So we go 1 plus 2 plus 3 plus 4 plus 5 plus 6. Okay, so there's only not one way. We can write it in many forms. let's say if I say I want to start I from 0, somebody says I don't like 1. Oh, okay, we'll work with you too. But we'll get exactly 1 to 6, but I'll write it in a different form. So somebody says I like to start from 0. Oh, okay, let's do from 0. So we say I goes from 0. And here it is going to be a change because we want exactly 1 to appear first. So I say I plus 1. So that when I put I to be 0 here, it becomes 1. Now remember, I have to go only till 6. So that means my I can only go till 5. So it's 0 to 5, and at the end I get a 6. So these, notice, are exactly the same. This expression is the same. But I'm representing in a concise form in different ways. It does not matter. In the end, if I'm looking for the result, I go from this way or this way. Does not matter. Okay, now let's try another example where I say, it's not always going to be from 0 or 1. I say, somebody says, oh, I want like 3. Oh, okay, let's work with 3. And what is the summand here? It says, whatever you start from, it has to be squared. And then you add up all the terms. So he says, I start from 3, and then we continue 3 squared plus 4 squared, and we're going to go till 7. So 7 squared. So this is called the expanded form. This right-hand side is called the expanded form of the summation notation. This is called the summation notation in a concise form. The left-hand side, guys, is the concise form. Okay, we are not only going to be sticking with numbers, we can play around with variables too. Okay, so let's start here. I have a variable, say k. I'm going to vary the k. Now this n in this expression of the summand is constant. And this n can be anything. But I'm just trying, I don't like numbers. I like some, variables to be put. Okay, 1 over n. But in this expression, keep in mind this only k is varying because what you are writing below the summation symbol is the one which will vary. Rest everything will remain the same. It says I start from 1, but I continue till this n. Now this n and this n are the same, guys. Okay, here in this summand or the expression 1 over n will be fixed. But the terms which is changing is k. Keep this in mind. The change is happening here. So that's where the change is. 1 squared, 2 squared, and it's going to continue till this n. Okay? It's not that every time we have to see some numbers popping up. We can do something else also. Here, if I have an expression, here it was like we were giving exactly the expressions. Here I'm saying, oh, I have a function. Good. I can make the changes here. So if it f of xi times a delta x. Now this delta x can be anything. It's just like you can put a smiley face if you like. So here this is constant. It is going to remain the same. Delta x all. But where is the change? Change is happening here in this I. So when we write down the expanded form, it is f of x1, f of x2, f of xn. Remember, when you see the summation symbol between every expression from the first term till the last term, I will always have a plus in between. These are certain terminologies and concepts we got to keep in mind. Okay, as I said once again, when I write this summation notation, the right-hand side is called the expanded form, whereas the left-hand side is the summation notation in the concise form. So let's see how questions can be given. So the first question is, write this summation notation in the expanded form. That means I want to open this up. I don't want the summation symbol, rather I want all the terms with the plus in between. Okay, so let's write that down. So the first thing is, remember, this part is the left-hand side of the equal sign. Now we want to write down the right-hand side of the equal sign. So let's write down what is given to us. This is the left-hand side of the equal sign. And the expression has this. Notice, the vary is where. When you look at this expression, you look what is varying and where are we starting from. So it is the I which varies. It starts from 1 and goes till 4. Okay, so every time you see an I, you start with 1 and then you add 1 number next to it. So we start with 1. So it's going to be 2. There's going to be a 1 because 2I. plus 1 over 3 times 1. So that's the first term. Then a big plus. Now we have covered 1. We go to the next. We're going to go till 4, remember. So it's 2, 2, plus 1. Remember, everything else remains the same. Only the I will vary, guys. Plus. The next one is what? 2, 3, plus 1 over 3 times 3. And then the final expression, guys, is we have to go to, remember, we have to go where? Till 4. So this will be plus 2 times 4 plus 1 over 3 times 4. And that's it. Remember, we're not solving it. We're just saying, are we able to write this in the expanded form? That's what the question is saying. It's not saying solve it. It says apply what we have learned. That is how the movement is happening in I. I want to write it totally in the expanded form. That's what we are looking at, guys. Okay, now let's go from the other way side. In other words, if I give you this expanded notation, can you write me this concise summation notation? So we're going to go backwards here. So that's what we are doing in the next problem. We are given the expanded form. I want to write it in the summation notation form. That's what I want to write. So notice what's happening. The top is changing. It's 2, 3, 4, and it goes till 10. Okay. Even the denominator is changing. 1, 2, oh, this should be a 3, guys. A typo. Up to 11. So notice some things. The change is happening in the top, the change is happening in the bottom. Okay, and every time there's a change, it increases by 1. So it starts from 1, goes to 1. So notice we start from 1, we go till 11 in the denominator. In the numerator, we start from 2 and we go till 10. The difference between the numerator and denominator is by 1. So if I want to start from 1, okay, so I say it's an I, and I want to start from 1. That means I'm taking this. But the top is 1 more than bottom. So how will I write this expression? And there's a square in the denominator. So it's I squared. Okay, good. So we get this part. The top is 1 more than the 1 in the bottom. So it's I plus 1. Okay, I think I've made a mistake. 4 and 3. So this, guys, is going to be 9. Sorry. Yeah, this is 9. Some typos, guys. This is 9 because it is 1 more than the top. So that's how it will go. So here, we start from 1, go till 9. So summation goes I from 1 to 9. And the bottom goes 1 square till 9 square. And the top will go 1 extra than that. So if it is I is 1, the top is 2. I is 3, the top is 4. So I is 9, the top is 10. But in the denominator, we have a square. So this is the right way to write. Let me write it in a much more nicer form for you guys. So summation I varies from 1 to 9. The expression is I plus 1 over I squared. Okay, now let's look at some rules of these summations. They are very, very helpful. The first rule, guys, is that if you multiply a constant with an expression, the constant can be pulled out. If you're adding and you're going from 1 to n, so like this, you can say, I have 3 times 1 plus, 3 times 2 plus 3 times 3. So notice 3 is common. So I can basically pull 3 out and it is 1 plus 2 plus 3. So that's what basically this is meaning. Okay. So this is like the idea I'm taking. I can take the constant out. Now if you're adding and subtracting 2 terms and doing a summation over this, you can basically pull them apart. Now let's look at this one. This means summation I 1 to n to k. That means if I'm adding k, say 5 times. So I have this number, say 7, say. And I want to add it 5 times. 7 plus 7 plus 7 plus 7. So 3, 5. Do you see that here? So I can write it in a nice form. It says, hey, this is the same thing as saying summation 7. And I varies from 1 to 5. That's what it means. That's what k. So if you're adding a constant 5 times, 6 times, or whatever times you want to add, you can write it in a nice little form like this. Now, this is the summation of the first n terms. Summation of I is n into n plus 1 by 2. Now these, and then summation of I square, n times n plus 1 times 2n plus 1 divided by 6. And then summation of the first, cube terms, it's n squared times n plus 1 the whole square by 4. Guys, these ones, very, very important. These are very important, guys. And I would like you guys to, when you do problems, keep this rule of summation handy in front of you when you're doing problems, because you'll be using them to solve a lot of the questions here in section 4-2. Okay, let's look at this one. Use the above rules to evaluate. So we're going to look at an example here. It says use the above rules to evaluate summation I from 1 to 20, 2i cubed minus 3i plus 4 in the expanded form. Now, we're going to go slowly. We're going to go one at a time. So the first thing is, because there are 3 terms in this expression, and they are joined by a negative and a positive. Now we can pull them apart. So let's do that. Pull them apart. By the way, this is 20. Okay, let's keep 20. Doesn't matter. So what is this? This is summation I varies from 1 to 20, 2i cubed minus summation 3i, I varies from 1 to 20, plus summation 4, I varies from 1 to 20. Now notice, this is, you're basically adding 4 20 times. So it's simply, if you're adding 4 20 times, it's simply 4 times 20. Now here, it's minus summation 3i. Now remember, we know the addition formula for summation of the first n terms. Now 3 is a constant, you can just basically pull that out. So minus 3 summation I varies from 1 to 20. Let's look at this one. It's a constant multiplied to I cubed. Now we know the formula for summation I cubed. We just need to pull the 2 out. 2 summation I varies from 1 to 20 I cubed. Okay, so now we have to apply the formulas here. Guys, go to the previous slide, number 7 here. We'll be using this formula and using this formula. Now, once you have written it down in the correct form, remember we have used this summation I from 1 to 24. It's n times k. And then we applied the second formula here. And then the constant. Basically, we've used 1, 2, 3, 4, 5. Almost all. 90% of you have kind of taken care of. Okay. So, let's look at this one. 2. I'm going to just plug in the formulas. Now, remember, I'm going to just write down the formulas for you. You know that. Summation. I'm going to talk about I. I varying from 1 to n is given by what? N into n plus 1 by 2. Now, if you're looking at the cubes of the first n terms, I varies from 1 to n. The formula is n squared, n plus 1 squared divided by 4. So these are the formulas we would be needing. Now, over here for the I cube, that's what we apply. Now, what is my n? N is 20. So this is 20 square, 20 plus 1, 21 square over 4. Then minus 3. Now this n is 20. It is 20 times 21 divided by 2. Then plus 4 times 20 is 80. Now after that, just plug in your numbers. Okay, just let's do that. So now here 2 goes 2 times, and this 2 goes 10 times. So this is what? 30 times 21. So let's take the calculator out. We can easily do that. You're getting 630 here. So you're getting minus 630 plus 80 from here. Now let's look at 20 square is what? 400. 400 times 21 square is what? Multiply that, you get 1676400. You divide by 2, you get 88, 200, and then you just do the math. And you're getting is 87650. Now, very important, guys, is when you're doing this in your exams or written assignments, for when I grade, I basically look at this part. These three are the most important grading points. Very important to keep these things in mind when you're practicing, because you need to know what you're doing, what is the appropriate formulas, are you keeping the numbers handy. So these three lines, very, very important for us. Okay, so we will continue later with area of a plane region. Thank you.